my class 10 students, a very warm welcome to Deeksha Vedantu YouTube channel. I'm your Aditi Mam, and you know we have started the OG series to ace your class 10th boards, and the next episode of that series is today's, that is your chemical reactions and equations, which as you know is of chemistry lecture. Now this chapter, my bacha, is very important. Okay, it makes the base of your class 10th or chemistry of your class 11th and class 12th as well, if you are going to take science ahead, right? Now we'll start with what are chemical reactions, what are chemical equations, what are chemical formulas, how to balance them, and all that stuff, different kind of chemical reactions, equations. We will see all of that, and I know it can be a little bit boring, but your Aditi Mam is here, and when I'm here, the chapter will not be boring at all. Okay, so let's start with the very first. How many of you drink tea? You drink tea? Or how many of you know how to make tea or chai, as we call it, right? That hot, piping hot chai we drink even in the summers, right? So how many of you know how to make that? You know that we combine, make sure when I put stress on some words, those are important. Okay, so we combine few ingredients. Let's say those ingredients are water, milk, tea leaves, jaggery or sugar, right? So we combine all those and we heat them, right? And after that whole process, somehow all these ingredients combine together and make a beautiful product that is very tasty. That's our chai. I love chai. Okay, now talking about this chai, what actually happened here? You took lots of ingredients, combined them, it got formed into some other thing, right? Now these ingredients that you took, my bacha, these ingredients, these are tea leaves. Okay, wait, these are tea leaves, right? These are water, and this was then milk, and then all these stuffs, these are called reactants. These are called reactants. See beta, along with wait, what is this lighting? Wait, let me correct this. Okay, along with these very interesting, chai and making all that, we are going to study a bit of chemistry as well, right? So these are reactants, right? Reactants combine together to form a very tasty chai, and this chai is our product. You know by this now. I am hoping that you know this much basic information by now, right? Now what are all these happenings? What we will be learning in this chapter is very important. Now what will be these learning points? Just like this, just like making chai, we will be looking at lots of chemical reactions, lots of chemical equations, not too much but a little bit. Okay, now we will see chemical equations, we will see how to write these chemical equations, how to balance these chemical equations. I have already put a video for how to write chemical formulas, okay, and soon I'll be putting out the video of how to balance these chemical equations. I will share that in this video also, but you can watch that as well. I have practiced you, okay? I will make sure that you practice all those chemical formulas in those videos as well, and balancing as well. Okay, now moving on to, we will see a lots of chemical reactions, combination, decomposition, displacement, and mind you, if you have not able to understand those in schools, do not worry, you will understand everything, because just like chai, I have so many interesting examples. Okay, so we will understand those properly, and then we will see a little bit of deep science, that is oxidation, reduction, oxidizing and reducing agents, or these effects of these reactions in our everyday life. Okay, now let's start with our very first. What is a chemical reaction? A chemical reaction, bacha, it is a process. It is a process in which two or more reactants combine together to form a product, two of more, which one or more substances is changed or transformed into a new compound with new chemical formula or new chemical properties. It is called rearrangement of atoms. It is called rearrangement of atoms. In tea leaves, in water, in milk, atoms were rearranged in a different manner. When we heated it and combined them all together, it was formed into chai, and the atoms are rearranged into a different pattern. That's how its properties are changed, right? And that is what a chemical reaction is. Okay, now for a little bit more scientific example, we have calcium plus O2. Calcium plus O2. When you combine these two, it becomes calcium oxide. So you combined two different atoms or elements, let's say. You combine two different elements, it produced a different product which has different rearrangement of atoms, different properties, right? And similarly, here reactants are what? Calcium and oxygen. Products are what? Calcium oxide. Understood? Very clear, very basic. Okay. Moving on, we have characteristics of chemical reaction. See, remember when I told you that we make chai, what do? We heat it, right? We heat it. And while heating, we see that chai is piping hot, right? So heat is coming out of the chai, because if you keep the chai for so much time and you're lazy and go take the chai, if you keep it here in the environment, it gets cold, right? So what is happening? Heat is coming out of that chai, right? So we can say that is a characteristics of the chemical reaction, that when so many ingredients are combined and heated, a lot of heat is generated and aroma is generated, right? The color of the chai changes, the smell of the chai changes. So all these are characteristics of our chemical reaction, right? Understood? So what can be these? This is change in state. So in chai, the change of state does not really happen, but we'll study what change in state requires. Okay, you have naphthalene balls. You know about naphthalene balls. If you keep them in this environment for so long, let's say 10-15 days, you see they will evaporate. We'll call that combustion. You must have studied it, right? So the naphthalene balls changed from a solid ball to a gas. That means change of state is happening. So change of state can happen. Change in color, chai changes its color, right? Change in temperature, the temperature of the chai also changes. No matter we give it heat, we are giving it heat, but that's a part of the chemical reaction. The giving of the heat is a part of the chemical reaction, right? Then evolution of gas. So sometimes when you combine those chemicals, you see lots of gas is coming out, lots of stuff is coming out. What is that? Evolution of gas. Then, so these are some of the characteristics of chemical reaction. What are the characteristics? Change in state, change in color, change in evolution of gas, and change in temperature. Change in state, change in color, change in temperature, evolution of gas. Understood? And keep thinking about chai. What's happening in chai? Color is changing, temperature is changing, evolution of gas will happen in some other time. Color is changing, temperature is changing, right? Okay, next moving on to what is a chemical equation. Bacha, till now we have studied what is a chemical reaction. Chemical reaction and chemical equation are two very, very different things. Okay, now what is a chemical equation? What a chemical equation is the symbolic representation of a chemical reaction. Now, what do I mean by that? When I say that I combined water, when I say that I combined water with tea leaves, I get a green tea, right? I get a green tea. Now, we don't have a specific symbol for tea right now. You don't have it in your syllabus. But for water, can I write H2O? This is what? It's a symbolical representation. This is a symbolic representation of what? It's a representation of water. So instead of writing complete water, we gave it a formula that is H2O. Why? Because it is made up of 2 atoms of hydrogen and 1 atom of oxygen. Understood? So why we we do that? To make our work a little bit easy. When you write hydrogen plus oxygen equals to water, it's really tough, right? So instead we can just write H2 plus O2. H2 plus O2 gives H2O. How hard was that? How hard was that? And we will do the chemical balancing because this will come as this. Okay, we will understand the equation, balancing of the equation as well, but you understand why we use the chemical formulas, why we use the symbols. So a symbolic representation of a chemical reaction is called a chemical equation. It can be written in three forms. Now word equation is simply hydrogen, oxygen, water. You can write it. But skeletal equation is H2 plus O2 equals to H2O. That is also fine. But we are good people. We are smart people. We will balance the equation, and the balanced equation will be 2H2 plus O2 gives 2H2O. Understood? We are making water people, and we will need water in our future, I guess, looking at the world. Okay. Now, next is what are balanced chemical equations. Okay, before that, we were talking about chai, and your ma'am is a huge chai paglu. So, I have gotten myself a chai so that I can teach you very with full energy, right? So, what is a balanced equation, bacha? Balanced equation is what we studied, right? H2 plus O2 gives H2O. But this is not balanced. Let's see. H2, what is happening with this marker? Okay, H2 plus O2 gives H2O. Here hydrogen are 2, but oxygen is also 2, oxygen is also 1, right? But why do we need to balance a chemical equation is the question. Why do we need to balance a chemical equation? Ma'am, I have studied a very important law, that is conservation of mass. So if I combine tea leaves, if I combine water and milk, I should get that amount of chai, right? If I put more water, I will get more amount of chai, more milk, more amount of chai, more tea leaves, more bitter chai, right? So characteristics of chemical equation are changing, reaction are changing. But why? Because the mass of products should be equal to the mass of reactants. The mass of our products should be equal to the mass of our reactants. Why? Because we have studied that mass can neither be created nor be destroyed, but can be changed from one form to another. Understood? That is why we need balancing, to balance the mass of reactants and products. Now, we have talked a lot about why we need balancing. Let's study how to do balancing, okay? So, basically, balanced equation is that in which total number of atoms of each element are equal on both the sides of the equation. These are the product side, these are the reactant side. The number of atoms of H2 should be equal to the number of atoms of H2 on this side. The number of O2 on the reactant side should be equal to the number of oxygen on the product side, right? That is what is called a balanced chemical equation. Now there are 4 easy steps. Let's understand how to balance first, and then we'll come back to balancing of chemical equation, right? I'm thinking the light is a little bit not better. Let me just give me 1 minute, bacha. Just give me 1 minute. Is it better now? Is it? I hope it's better now. Nope. Wait. Yeah, okay. Now it should be good. Now, how should we balance the chemical equation? How should we balance the chemical equation? There are few steps that you need to see, okay? Now, let's write the basic equation, that is Fe plus H2O gives Fe3O4. Right now, you won't understand this chemical equation. That is fine. But we are just understanding how the balancing will work, okay? So, this is iron plus water. This is iron plus water gives iron oxide. We will study, okay? Fe3O4 plus H2. Now, how should I balance this chemical reaction? Now, 3 things or 4 things you have to remember. First of all, the first thing we have to do is balance the metals. metals. What are metals? Potassium, sodium, silver, copper, magnesium, zinc, calcium. How will you remember these? Practice. Okay, how will you remember these? By practice, bacha. Only practice will save you from chemistry. Trust me, I have studied it. Okay, then non-metals we have chlorine, bromine, silicon, nitrogen, and okay, carbon, potassium. All these, sorry, not potassium, phosphorus. Okay, so all these are non-metals, or these are metals, right? And then we have oxygen, then hydrogen. So first we will balance our metals, then we will balance our non-metals, then we will balance our oxygen, then we will balance our hydrogen. Okay, let's try to do it, right? Now here is iron. Iron is, the number of atoms in iron is what? Let me just write it again. Okay, iron plus H2O gives Fe3O4 plus hydrogen. This is the equation, correct? Now what you have to do, you make a table. Okay, you make a table, a simple table, and in that table what you have to do, you write element, and this is the reactant side, this is the product side. This is the reactant. How much reactants we had? Iron, hydrogen, and we have a third one as well, that is oxygen. Understood? It's an easy way to do it, and once you practice it, you don't have to make the table every time, right? You will be so quick, you will understand within your mind only, right? Because I will make you practice. Now in the reactant side, iron is what? Only 1. In the reactant side, iron is only 1. So I will write 1 here. In the product side, iron is 3. Right? Iron is 3. Okay. In the hydrogen, in the reactant side, hydrogen is 2. In the reactant side, hydrogen is also 2. So hydrogen is already balanced. Oxygen is only 1. And here oxygen is 4. 4 oxygen. So I have to balance this. Why? To conserve, to apply the law of conservation of mass. Now what should I do? I will balance metals first. So out of these, O and oxygen, here there are no non-metals. So it is very easy. So H and O I will balance after. First I will balance iron. See, one thing is, you will never ever write numbers in the foot of the element while balancing. Okay, I cannot write Fe3. That is wrong. I cannot write Fe3. That will be wrong. You always have to write in front while. See, this is nature. Okay, nature has given this Fe3 element. We cannot put 3 ourselves. That is like changing the element. Okay, now we can put here, that means 3 elements of Fe. So now Fe becomes 3. Okay, Fe is balanced. H was already balanced. We just have to balance O. Now see, O is 4 here. Now here is O is only 1. So if I put 4 here in front of H2, so O is balanced. O became 4. Okay. But in doing that, we unbalanced hydrogen. Hydrogen was 2. Now hydrogen is what? 4 into 2. 8 hydrogen is here. Now 8 hydrogen got here. So we have to again balance the hydrogen. So here is 2. If I multiply this 2 by 4, it will become 8, right? So if I multiply this 2 by 4, this will become 8. Now see hydrogen, 4 into 2, 8 hydrogen. 4 into 2, 8 hydrogens. Now is it balanced? Now let's just to see that if we balanced or not, let's just make another table, and this is the reactant side, this is product side. Iron is what? 3. Iron is 3. So this is balanced. Hydrogen is 4 into 2, 8. 4 into 2, 8. This is balanced. Oxygen is what? 4, and oxygen is what? 4. So both are balanced, my friend, and we are pretty successful, right? Done. Okay, let's move back to another example. We have one more, Al2O3. Let me write it. Al2O3 plus HCl plus HCl will give us AlCl3 plus H2O. This is the equation, my friend. This is the equation. Okay. Now how to balance it? Let's try to do it without making a diagram. Okay, I'll give you 2 seconds. I'll give you 2 seconds and try to solve it by yourself. Okay, try to solve this by yourself. Until then, ma'am is having a little bit sip of chai. Okay, done. Now, A2O3, did you make it with the box or without the box? Let me know in the comment section what's the answer. Okay, I will check. Slide number 13. This is slide number 13. Write the answer in the comments. Okay, now Al2, Al is only 1. Let's just do it without the box. Okay, if I write the element directly here, Al is 2, but here Al is 1. So I have to balance Al first because that is a metal, right? Now, for that to happen, Al2 is here. If I apply 2 in front of Al, while balancing, you should use only whole numbers. You cannot use fractions, you cannot use decimals, you cannot use 1 by 2. You cannot just write here 1 by 2, right? Then half into 2 of aluminium, it's 1. No, that's not true. Okay, bacha? You have to always use whole numbers. I think you have studied whole numbers in 9th, right? Okay, so 2 of aluminiums and now aluminium are 2. Okay, now they are balanced. 2 aluminiums. Okay, so aluminium is balanced. Done. Let's move to Cl. That is our non-metal in this case. So Cl is 1. Here see, Cl was already 3. We put 2 here. So 2 into 3, 6. Cl became 6 here, right? Here Cl is only 1. So if I multiply Cl with 6, both of these are balanced. So I multiplied Cl with 6 and both of these are balanced. Okay, now Al is balanced, Cl is balanced, we have O and H. What will be balanced next? We will balance O, right? So O is what? O is 3 here, right? But here O is only 1. O is only 1. So if I multiply O with 3, it will become 3O, right? Simple. You see how simple is it? So now O is 3. Now we have 3O and we have 3O here as well. We just have to balance H. H is 6 here. Oh, H is already balanced. In balancing all those other things, H got balanced. So H is already 6. Now here H is also 6. So our whole equation is balanced. Now let's see if the equation is balanced or not. Finally, why, ma'am? We just balanced. Rechecking. It is very important in your boards and you will make mistakes because I did as well. Right? So aluminium, chlorine, oxygen, hydrogen, reactants and products. This is our whole table. You can make it before balancing as well. But if you want, you can also try without making this table so that you practice a little bit. Okay. Now, aluminium is what? 2. Aluminium is 2. Done. O is, chlorine is 6 here. Chlorine is 2 into 3, 6 here. Oxygen is 3 here. And oxygen is 3O. That is 3 here. Hydrogen is 6 here. 3 into 2, 6 here. So, this also became balanced, my friend. Right? So, what we did? We counted the number of atoms on both sides, made a table of an unbalanced atoms, then we balanced all the atoms, then we made a table of balanced atoms. Done. 4 steps, only 4 steps you have to do, and while you practice you will see you won't have to make the table at all, right? Okay, next we have lots of stuff to practice. Finally, okay, Cu2O plus Cu2S gives Cu plus SO2. Now, see, Cu is 2 here, Cu is 2 here, Cu is 2 here. Okay, let's just do with the table first for your convenience. Right, we have Cu, we have oxygen and sulfur. Is it visible to you guys? Okay, let me change the color. Yeah, so Cu, S and S and O, right? And this is reactants and product table, right? Reactant table, product table. Now Cu is what? 2 here, 2 here. 4 Cus are there in reactants. Only 1 Cu is there. S is 1, S is 1 here, S is also 1 here, O is 1 here, O is 2 here. So C, we will try to balance this. Now, copper in reactant side is 4. If I multiply the product side copper with 4, it will get balanced. So I'll just multiply this with 4. 4 copper here, 4 copper here. Done. Okay, then moving on to sulfur. Sulfur is only 1 here and sulfur is only 1 here. So it's already balanced, right? It is already balanced. Done. So copper balanced, sulfur balanced. Coming back to oxygen. Now in reactant side we have only 1 oxygen. In product side we have 2 oxygen. That means we have to multiply the reactant side oxygen with 2. But I cannot multiply 2 here in the foot, right? I have to do it in the starting. Okay, ma'am. So, oxygen also got balanced. But ma'am, wait. In balancing oxygen, we unbalanced copper. Now, there are not 4 coppers on the reactant side. There are 2 into 2, 4 plus 2, 6 coppers here. Now, there are 6 coppers here. Now, what should we do, ma'am? Just multiply this 1 by 6, right? So, if instead of this 4, right? 6. So, let's see if this balance. 2 into 2, 4 plus 2. 4 plus 2, 6 copper here, 6 copper here. Okay, copper is balanced. Then 2 oxygen here, 2 oxygen here. Oxygen is also balanced. 1 sulfur here, 1 sulfur here. Sulfur is also balanced and hence the equation is balanced. Understood? Understood, everyone? If you have any doubt, you can let me know in the comment section. I read all the comments, okay? I even comment under your comments as well if you have any doubts. Okay. Let's move on to the second equation. The first equation is done. Second equation. BaCl2 plus Al2SO4 thrice. How do you say this? Al2SO4. If you have whole bracket, you say thrice. Then BaSO4 is a product and AlCl3. Okay, let's make the table again. Let's make the table again, my friend. Okay, we have BaClAl. Oh, we have lots of reactants. Let me use another slide, okay? BaCl2 plus Al2SO4 thrice, Al2SO4 thrice, and BaSO4 plus AlCl3, BaSO4 plus AlCl3. Now this is our normal equation. Done. Now let's make the table. This is reactants, this is products. Let's make it a little bit wide because we have to cut the elements as well, right? So this is reactants, products, this is our element, this is the table. Okay, now we have aluminium here. Okay, write it from here. Barium here, we have barium here, chlorine here, aluminium here, we have S here, we have O here, and we have, see, when you are given with SO4, you will completely simply can write SO4, provided that it's not breaking in the product side. It can sometimes, okay, it can sometimes. So you have to take take this very carefully, okay. Let's just write now, let's just practice with S and O, you will understand better. Okay, S and O, that's it, that's all the elements. Okay, then complete this table. Okay, so let's see first barium. The reactant side, this is the reactant side, barium is only 1. In product side, barium is only 1. Great. Now in reactant side, chlorine is what? 2. There are 2 chlorines, and in here there are 3 chlorines. So in reactant side we have 2 chlorines, in product side we have 3 chlorines. Okay, then aluminium. In the reactant side we have 2 aluminiums, and in the product side we have only one aluminium, right? 1 aluminium. Then sulfur is 3, S3. This 3 will multiply inside. So sulfur is only 1 into 3, 3. So sulfur is 3 here, and in here sulfur is only 1. Sulfur is only 1. Now O is what? 4 into 3. 12 O's are there. 12 O's are there, but here only 4 O's are there, right? 4 O's are there. So which one is balanced? Only barium is balanced, right? Now we have to balance Cl, Al, S and O. What will we start with? We'll start with metal. Now barium is already balanced. We'll move to aluminium. Now aluminium, see, Al2, Al only 1. So I'll multiply there with 2, right? It will balance, right? I will multiply Al with 2. Now Al is 2, Al is 2. So Al is 2 now. Balanced, understood. Okay. Now we move on to chlorine because this is our metal. So we will balance it first. Wait. Let me write that here, okay? You'll be better understand that, right? So aluminium is a metal, so we will balance it the first number. Then chlorine is a non-metal, so we will balance it on the second number, right? So chlorine, see, chlorine is 2 here, chlorine is 3 here, understand? But now chlorine is not 3 here, chlorine becomes 2 into 3. 2 into 3, 6. So chlorine on the product side is not 3 now. It became 6. Understood? Go very carefully, very slowly. It's very important that you understand all that. Chlorine, we balanced aluminium, we put 2. But why balancing aluminium, we unbalanced chlorine, right? The 2 into 3 chlorine becomes 6 here. Now in here, on this reactant side, we also have to make this 2 into 6, right? So if I multiply 2 into 3, it will become 6. Right? So if I multiply 2 into this 3, it will become 6. Right? Understood? Now chlorine is what? Now chlorine is 6. So chlorine is balanced, aluminium is balanced. But now while balancing chlorine, we unbalanced barium. So barium is 3 here now. Barium is 3 here now, and in here barium is already only 1. Right? So I'll just multiply 1 with 3 and this will become 3 and I'll put 3 here. Is that difficult? I know there are lots of steps, but are these difficult? Just basic simple math, right? Some hit and trial, some basic simple math, but we have a specific list. Metals, non-metals, oxygen, hydrogen. So we moved to aluminium first, then we moved into chlorine because barium was already balanced. But while balancing chlorine, we unbalanced barium, so we balanced barium as well. So on the third number, we balanced barium. Right? Now see, barium is balanced 3, 3. Chlorine is balanced 6, 6. 3 into 2, 6. 3 into 2, 2 into 3, 6. So these are balanced. Aluminium 2 and aluminium here there is already 2. Right? Now we move on to sulfur. Right? Now we move on to sulfur. Sulfur is 3 here, here it is 1. But now sulfur is not 1. Sulfur became 3. See, this 3 will multiply both with barium as well as sulfur as well as with oxygen. Okay. So, okay, let me just keep it here. Okay. This 3 will be multiplied with all these 3. Okay. This is a multiply sign. So, now sulfur is what? Sulfur became 3. So, sulfur also got balanced. And oxygen 3 into 4, 12. Oxygen also got balanced. Okay. So now all are balanced. See, you just have to use a little bit of your brain in the first section, right? And every other thing just fell into place, right? So keep focus, keep a little bit of, what do you say? A little bit of bharosa, trust on God as well as your Aditi Mam, and things will fall into place. Okay. Now, understood this chemical equation? If you have any doubt, just ask me in the comment section and I will be coming live for this chapter as well, so you can ask your questions then also. Done? Okay, let's move on to the third. Now this is your homework. Okay, I have done a very easy as well, a very tough as well, and this is very simple. Just like we solved SO4 thrice, you will use NO3 twice. So PB is 1 here, N is 2 here, O is 3 into 2, 6 here. Here PB is 1, O is 1, N is 1, O is 2, O is 2. So O here is on the product side, 2 plus 2 plus 1, O is 5. But in the reactant side, O is 6. O is in the, this is product side, 6 in the reactant side. So you just have to balance O because Oh, N is also here. N is 1 on the product side, 2 on the reactant side. So just use the hit and trial method and let me know the answer in the comments. Okay? Answer in comments. You have to give the answer in comments. I'm not saying answer will be in the comments. You have to give the answer in the comments. Okay? Slide number, we have slide number 14. Okay. Done? Understood? Okay, let's move on to the next topic, a very important one. And okay, that is a question. Oh, that is a question. Now understand what kind of questions you will get in your exams. They will give you, consider the following chemical equation. Okay, P into Al plus Q into H2O plus R into Al2O3 plus S into H2. Now you may ask, ma'am, what is this PQRS? They have given you. To balance this chemical equation, the values P, Q, R and S must be respectively. So they are asking what will be PQRS? 1, 2, 3, 4, 5, what? Because when we balance, we will put the, like, aluminium is 2 here, right? So to balance this, I will put a 2 here. That means P is 2. Understood? This is how you work. Let's do it. Let's do it. Okay. Aluminium is 1 here. Let's make a box. Where should I make a box? Here. Okay. We have aluminium. We have H and O. I think we did balance it before, right? Oxygen and hydrogen. We have reactants and product side. On the reactant side, aluminium is simply 1. Here aluminium is 2. Understood? Understood? Then we have oxygen 1, oxygen 3, oxygen 1, oxygen 3, hydrogen 2, hydrogen 2, hydrogen 2, hydrogen 2. So on the first glance, you will say, ma'am, hydrogen is already balanced. But we have to balance our metal first. Then we'll go to non-metal, then oxygen, then hydrogen. And in that doing so, we might unbalance hydrogen as well. Right? We did it, right? So first we will balance aluminium. Now here if I just multiply it with 2, this will get balanced. So here I will just multiply this with 2. Easy. Then balancing oxygen. Now oxygen is 3 here. Here oxygen is also only oxygen is only 1. So if I multiply this with 3, oxygen becomes balanced. But what did I say? We unbalanced hydrogen. Now hydrogen is 2 only here. In here in the reactant side it is through into 2. That is 6. So if I multiply here with 3, this becomes 6. Ma'am, it was easy. It was easy peasy lemon squeezy. Right? So this is 2 aluminium, 2 aluminium, 3 into 6, 3 into 2, 6 hydrogens, 3 into 2, 6 hydrogens, 3 oxygen, 3 oxygen. Balanced. Now, how do you write the answer? You cannot leave your answer till here. How do you say? With aluminium, we have P. That means P equals to 2. With H2O, we have Q. That means Q equals to 3. Right? With R, with Al2O3, we have R. And in here, we don't have anything with Al2O3. So R is simply 1, right? Because these are already balanced. And S with hydrogen, S is 3. So this, my friend, is your final answer. This is your final answer, bacha. Understood? Any doubt? Any doubt? Understood, right? Okay. Next we have another same kind of example, same question, that is your homework. You think ma'am is giving so many questions in homework. No, I got these questions to give homework to you because you should study. Okay. So I'll tell you, see, in order to balance the below chemical equation, the value of X, Y and Z respectively are. Now what are X and Z? X is with HCl, Y is with H2O, Z is with Cl2. So after you balance, whatever the number comes here, 2, 2, let's say 3. So X is 3. Okay, Y will be 2 and Z will be 2. This is just an example. Okay, just like we did in the above question, you make sure you do it like this and you have to answer in the comments. Answer in the comments. Write your answer in the comments. Let me just write in the here. Okay, because I think you guys understand that answer in the comments means I am going to write answer in the comments. So write answer in the comments. Slide number, you write slide number, that is 16, and then your answer. Okay, you just write x equals to 2, y equals to 3, whatever. Okay, whatever you get, sorry. Okay, let's move on to the next thing. How to make a chemical equation more informative. Ma'am, what does that mean? Why do I make a chemical equation more informative? I understand. Yes, you understand, but you understand it now, right? When I write that naphthalene balls, if I write that naphthalene balls, they got converted into air, right? They are empty, they're gone, tata, bye bye. Now what do you say happened here? Here the naphthalene balls were solid, they were in solid state, and here they are gaseous because they evaporated in the air, so they eventually turned into gas. It's not like they just disappeared, because energy or mass cannot be created, cannot be destroyed. It can be turned from one state to another. So it is turned from solid state to gaseous state, but we just don't see the gas. Right? Now, this, how will we know that naphthalene balls were gas or this was air or liquid? We have to define it, right? For naphthalene balls we know, for all other things we don't know, right? So what we do, whenever we write a chemical equation, we specify that it's a solid, we specify that water is a liquid, we specify that NaOH is aqueous solution, we specify that H2 is a gas. Okay, understood? And with these brackets we specify the physical state of the reactants, and products can be represented by using symbols like S for solid, L for liquid, G for gas, AQ for aqueous solutions. The word, now you might ask, ma'am, what is the difference between a liquid and an aqueous solution, right? So liquid, the word aqueous is written if the reactant and product is present as a solution in water. So we have something NaOH, it's a solution, it's something other than water inside water, but it is liquidy, but it's not completely water. So it is an aqueous solution. Aqueous if written if reactant or product is present at a solution in water. When you do a reaction of sodium and water, so you're mixing sodium with water, so the exact solution will be a liquid. It will be something sodium inside the water, and that is what an aqueous solution is. You get a final product in a beaker, right? That is it. Then precipitate can also be represented using an arrow pointing down. Now you will study something called precipitate or precipitation reaction. Now what are these? What are precipitates? See, whenever okay, whenever you put sand inside water, okay, this is just an example, not the exact meaning of precipitate, but whenever you put sand in water, for some time it will keep on you keep on stirring. For sometimes you will see it is like floating inside water, right? But as soon as you stop stirring, what will happen? It will settle down at the bottom, right? So that is called precipitate. Precipitate is something that settles down. Mainly it's a reaction in which some products, some reactants react, and some of the products settle down in the water or in some any other solution. So to depict that, we can either write P, but we don't generally do that. We make an arrow pointing downwards. That means whatever that solution is, whatever that thing is, it's settling down, right? And instead of using symbol S, okay, that is it. And gaseous state of an evolved gas can be represented by using an arrow pointing up. If the naphthalene balls are they evaporated, so we will write here they evaporated, they became a gas. If they precipitates in a solution, if they what is happening, if they precipitate, the solution precipitates, we'll say it goes down. Gas, obviously gas goes up, so an upward arrow for precipitate and downward arrow. This is how you represent, this is how you make your chemical equation a little bit more informative. You are telling now about the state of the chemical equation or the chemical reaction or the reactants and the products as well. Okay, very good. Now, types of reactions. Oh my god, this is what, we had like a FA tests, right? I forgot the whole sentence. Okay, the whole, what am I doing? Abbreviation of FA, right? But we have these monthly or quarterly tests. So I scored, like, I was very embarrassed, but I thought I studied all these chemical reactions, but there was this neutralization reaction, there is this combination reaction, and I just can't able to remember this. I'm like in 10th class, this chotu sa bachchu, but I'm not able to remember those. And I got, like, I was a good student, okay, 20 out of 20, 20 out of 19, 18, 20 was the marks we used to have tests, and I scored 13, and my teacher knew that I am a good student and will feel bad. She didn't give my copy in front of everyone. She like called me and was like, Aditi, and I was like, why didn't you give it? Just look at it. It's like 13 marks out of 20. I was so embarrassed. I was like, what the hell happened? Then I was like, okay, don't worry, that's not a big deal. It was a big deal back then, but now I understand. Then I worked on it, then I studied, and now I know actually how to remember these equations. I told you that story because to tell you, to make you believe in me that I scored 10 CGPA in science. Okay, we used to have CGPAs, that is like 96%. So I scored 95% in the whole length and in science as well. So I know how to study now. Okay, so let's start with the types of reactions. Types of reactions, bacha, we have different types of reactions. See, when I tell you naphthalene balls got evaporated, so that's a different type of reactions. When we made chai, that's a different type of reaction. When we mix some random elements in our chemistry lab in the school and a blast happens, that's a different kind of reaction. And sometimes the reaction is so cold, we have to put gloves, right? So that's a different kind of reaction. So all these kind of reactions have very different properties, and based on that properties we are going to study 4 different kinds of reactions: combination reaction, decomposition reaction, displacement reaction, double displacement reaction. Now, don't go on their names, okay? I have made it very easy, okay? So combination reaction is the same. See, tea leaves, we have tea leaves, we have water, we have milk. All these are doing what? They are combining together. They are combining. You took 2, 3, 4 different things and you combined them together, and we get a sweet, milky, adrak wali chai. Kadak chai, right? So what we are doing? We are combining these products and combining these reactants and making a product. That is exactly what a combination reaction is. A reaction in which 2 or more reactants combine to form a single product. This product is single, right? This is but ma'am, we also get tea leaves, the chai patti that we filter it. That chai patti and the chai is, we call that as a whole, right? That chai patti is a precipitate because it settles down. See, what a collecting the dots, right? Connecting the dots. Nice. Okay, so it's called a combination reaction. Why? Because we combined 2 or more reactants, formed a single product, and this is called combination reaction. I don't know what is this about lightning, but let's just focus on study. I think it's readable, right? Okay. Moving on, we have burning of magnesium ribbon. So you understand combination reaction, right? Now we have an example of magnesium ribbon. That is simply a ribbon made from magnesium element. Nothing that tough in this, right? Okay, so what exactly happened is we take magnesium. Now you can see what is the state of magnesium. It's solid, exactly, and O2 is a gas. From air we took it, and then we combine those and we get MgO. So the product is same, but with that we get heat as well. We don't consider heat as product, we consider as byproduct. That means we consider it as byproduct. That means our main focus was this product. Main focus was MgO, but we also got heat. That we can use it in some other way, or we can just let the heat go in the atmosphere. right? So we got MgO, that is white in color. Now magnesium solid, combine it with air, oxygen from the air, O2, that is in gaseous form, we make MgO, which is white in color. Done. This is a very important reaction. And what are the characteristics of this? See, whenever magnesium burns, right? Whenever magnesium burns with dazzling white flame, very bright light. So whenever you see that magnesium is burning, whenever we use that, we see a very white, dazzling, bright light coming out of it. Okay, then we have a white MgO powder in watch glass. Do you know watch glass? Okay, so do you know watch glass? How do you make? It's like a katori. It's like a tray. Okay, tray of glass, but it's little curved. Okay, little curved. It's like this kind of tray, but made of glass. So we use it in the chemistry lab to get the product, to make the product and put it in that, and watch glass. So we actually watch it, not just like sitting watch it, but we observe it in the watch glass because it's made of glass, right? And we can observe it very easily. So what they're saying, when we combine magnesium with air, it becomes MgO, and we put that in a watch glass, we get a white powder. Okay, and also white flames comes out of it with dazzling sounds as well. Okay, heat energy is releases, so temperature increases. We already seen that heat comes out of it. If heat comes out of it, that means temperature increases, right? And combination and exothermic reaction. We will read exothermic reaction in some time, do not worry. Okay, so this is a combination reaction. We combined magnesium, that is in solid form, with oxygen from air. It makes MgO. It gives dazzling white fumes as well as white powder. It increases the temperature because we get heat with it. And the last point is, it is called a combination reaction. Exothermic also, but we will study the exothermic in the last, and you will understand, you can relate then. Okay, I'll give you the PPTs and the PDFs of this as well, do not worry. Okay, then we have some questions, and I gave you the answers as well. Okay, no worries. So why do we rub magnesium with sandpaper? You know, when we burn this magnesium with the oxygen, we rub it with sandpaper. You know what sandpaper is? That very hard paper, right? We use it in sometimes carpentry and homes as well. So that is sandpaper. So why do we rub magnesium with sandpaper? Because whenever, see, this is a magnesium and it's in the air, so the oxygen reacts and it forms a magnesium oxide layer. It forms an MgO layer on it. That is what we studied, right? Mg with oxygen forms a white layer on it. Now to remove this layer, and get a fresh magnesium, pure magnesium ribbon, is why we use this sandpaper. We rub it, and the upper layer, the MgO layer, gets removed while we rub it, to remove any layer of magnesium oxide already present on the magnesium ribbon. Okay, why to keep magnesium ribbon away from your eyes? It's very easy, right? So we know that whenever the oxygen is combined with it, with magnesium, its heat is coming out of it, dazzling fumes are coming out of it. We don't want all those things in our eyes. As simple as that. That's why we have to keep that away from our eyes. What you can write in these two questions are very important for your exam beta. Okay, you can take a screenshot of those as well. Why to keep magnesium ribbon away from your eyes? Because the reaction is exothermic and it emits dazzling white light, so bright that you cannot see for a short time after looking at it. So if you see those, if you keep the magnesium here, you are having a magnesium in a watch glass and you reacted with oxygen and looking like this. Okay, maybe you have specs like me and you forgot that at home and you're looking at it, so white, so bright light of magnesium. So bright light, the dazzling white light will come out, and it is so bright that you won't be able to see for some time. Right? Because when we get a big flash, or when we look towards the sun, we are not able to see for some time when we look down, right? The same with magnesium, because the white light is so bright, we are unable to see with our eyes, right? For some time. Okay, that's why you have to keep it away from your eyes. Done? Okay, moving on, we have quicklime in water. See bacha, these are 2-3 important reactions of combination reaction. What is that? Burning of magnesium ribbon and quicklime in water. Now quicklime is what? Chuna. Okay, you have seen that white substance that the labor, whenever you are maybe building a house or doing some work on building, you get that white powder and you do the paint of it before doing the actual paint, right? So that is quicklime. What is that? Quicklime. That is what? Calcium oxide, CaO. Now CaO is obviously solid in the powder form. We call the powder form as solid only. Okay. When you combine it with water, so when you have seen, they take it in a bucket and they put water in it and they keep it away because lots of heat, lots of fumes come out of it. That is why when calcium oxide reacts with water, it gives us heat. But heat is what? Heat is a byproduct. What we need is calcium hydroxide, slaked lime, that is an aqueous solution. So you remember, whenever those workers put calcium oxide with water, they leave it, the heat goes up and they get a solution. They get an aqueous solution. That means calcium oxide in water, that is a aqueous solution. Very good. Now this reaction is also a combination reaction and its temperature is rising because we saw heat coming out of it. So its temperature is rising. Exothermic, let's say, I'll tell you a little bit. Exothermic is what? When the heat is released. When the heat is released, that means the reaction is exothermic. Understand? Now you'll get a gist of whenever we are talking about exothermic, when the temperature rises, it becomes exothermic because heat is releasing, right? Now, quicklime vigorously reacts with water. It means it reacts with water as like a boom. So, whenever you put water in that quicklime, it releases so many fumes, so many heat. So, it is vigorously reacting. Water added slowly because reaction is exothermic. If we put a lot of water in it, it will get heated in an instant and it will release so much heat. So, we put the water very slowly. Right? Now it is a combination because we combined these two things and we get calcium hydroxide, which is slaked lime. Quicklime combined with water makes slaked lime. Understood? So this is a combination reaction, exothermic reaction because heat is released, and quicklime used in making cement, right? So quicklime is what we use to make cement in our house. That white cement, right? That white cement is what? It is slaked lime. That is quicklime mixed with water. Understood? Okay, good. Now moving on to decomposition reaction. Ma'am, decomposition is what? Ma'am, sometimes some animal dies and it decomposes, the body decomposes, worms eat it. So sorry to give you that example, but that is decomposition reaction. Ma'am, that decomposition is biology. Ma'am, this is chemistry. Okay, so chemistry, let's study chemistry. What is decomposition reaction in chemistry? In the decomposition reaction, see, in combination reactions, two things combined to form a product. In decomposition reaction, we see that there are one product and it breaks down. That means it decomposes, it breaks down, form into two or more products. So basically, decomposition of biology and chemistry are almost the same. In these also, the worms are breaking down the body. In these also, we are breaking the reactant into two or more or one or more products. Understood? So what is it? A reaction in which single reactant breaks down into two or more products. Breaks down into two or more products is known as decomposition reaction. There are three ways in which decomposition reaction can happen. Now, if I have, let's say, any substance, okay, if I have plastic, I heat it, it will break or it will melt, right? So can I say the plastic decomposes when I heated it? right? So that is also a decomposition reaction, not in a chemistry manner, but in a general common sense life, it is a decomposition reaction, right? Now when you heat something and it decomposes, it's called thermal decomposition. It's called thermal decomposition. Those reactions which uses the energy in the form of heat. When you provide heat to the reactants and they break down into different products is called decomposition, thermal decomposition reaction. Now that is what? CaCO3. We have CaCO3, that is calcium carbonate. I have a different video where I tells you how to name these formulas. If you still don't know it, you can go and check that out. Understood? Now this is calcium carbonate, CaCO3. It breaks down when you heat it. This can be a symbol of heat or sunlight, because both are used to heat, right? So this is a symbol of heat. So CaCO3, when you heat it, it breaks down into calcium oxide plus carbon dioxide. Now this arrow means it is a gas, right? It is a gas, solid S. So calcium carbonate when heated converts into calcium oxide plus carbon dioxide. It is very important, bacha, very important. Every time you combine something with CaCO3, you will always get the product as CO2 and CaO. Always you get this, always. Okay, whenever you heat calcium carbonate, you are going to get CO2 every time, and with that we get CaO as well. So this whole reaction, when heated, it thermal decomposed into calcium oxide plus carbon dioxide. Understood? Okay, let's move on and see the next is electrolysis. You know, I gave an example earlier also. There are lots of, it's very expensive actually to break water into hydrogen and oxygen. We know water is H2O, and that means it's made up of hydrogen and oxygen. So basically it exists as water. But what if we have to break the water? We have to break the water into hydrogen and oxygen as well. So it is very expensive. Okay, very expensive. So how do we do it? By electrolysis. What is electrolysis? See, we will study that in some slides, but basically what we do is we take a beaker, we fill it with water, and we put two rods in it. One is anode. What is it? Anode, and the other is cathode. Okay, and oxygen, the H2O is here, right? And we pass current in it. When we pass the current, it breaks down, oxygen goes and deposits on the anode, hydrogen goes and deposits on the cathode. We will study it in very detail, do not worry. It's just a method I'm telling you to understand this a little bit. So electrolysis is breaking down of, we know decomposition is breaking down. So electrolysis, decomposition is breaking down of reactants with the help of current, electricity, electrolysis, right? So those reactions involve the use of electrical energy for the decomposition of the reactant molecules. So water, that is in liquid form, we apply electric current and it breaks down into hydrogen and oxygen. And now my bacha, you know how to balance it as well. The hydrogen is 2 here, it is 2, okay. Hydrogen, earlier, let's say we don't have this 2 and we don't have this 2, right? Now hydrogen is balanced, but oxygen is 1 here, oxygen is 2 here. So we'll balance oxygen, put a 2 here, but in doing that, hydrogen got unbalanced, so we put another 2 here. Easy, right? Okay. Next is photolysis. What is photolysis? The reaction involves the use of light energy. The reaction uses the light energy to decompose. So whenever we put silver bromide is an element, is a substance, right? It's in solid form. Whenever you put light on it, not the simple light, right? There is a specific beam of light or sunlight, we can say. So that is light energy. Whenever we keep it in sunlight, HV, you can also define H nu. H nu can be used as energy or sunlight energy. So whenever AgBr hits the sunlight, it breaks into silver and bromine. 2Ag, Br, 2 O2. It breaks into silver and bromine, silver bromide. When light is put on it, breaks into silver and bromine. Understood? And that is why it is used in black and white photography. It is used in black and white photography, this reaction. Okay, done. You have seen in the earlier days when there were films, not in my days actually, earlier than me as well, they used to take the film camera roll, they click a picture and you get printed on a page. Now there was a red light rooms for it, so you hang the photos and put a red light on it, so that photos have AGBR, it breaks into Ag, bromine, and that's how we get black and white photography. And that is why we say that it is used in Ag and is used in black and white photography, right? So we studied thermal decomposition, electrolysis and photolysis as well, 3 types of decomposition. Now I told you we will study electrolysis, right? So electrolysis is simply electrolysis of water, specifically is the process of breaking water into hydrogen and oxygen using electricity. I told you that. See, now are you able to see this diagram clearly? See, this is anode. I will write again. I don't think you are able to see this. Okay, now this part is anode. Okay, this is anode and it is positive, and this part is cathode, and this is negatively charged. We charged it. Okay, we charged anode positive, we charged cathode negative, and we put lots of water in it. Okay, now this is acidified water. This is, we put a little bit of acid because water is not a very good conductor of electricity. Pure water is a poor conductor of electricity. That is why we put few drops of sulfuric acid. What is sulfuric acid, my friend? Sulfuric acid is H2SO4. H2SO4. Understood? So what we do, pure water is not conducting, but we need electricity, so we put water in, so we put few drops of sulfuric acid inside the water. Okay, now when we put the electric current, when we turn on the current, what happens? All the hydrogen gas is released and it gets accumulated at cathode. Because hydrogen is positive, it will attracted with negative, so it deposits on cathode, and oxygen gas is released. O2 at anode, oxygen gas is released. Oxygen gas gets accumulated, so water broke into hydrogen and oxygen. Hydrogen on cathode, oxygen on anode. How I remembered this? Where what goes? So I just remembered OA. I don't know for what reason, but OA, I remember this for some reason. OA. Oxidation, anode, oxidation, anode, oxidation, anode. Okay, so oxygen anode, oxygen goes on, oxygen releases on anode, so that means cathode releases hydrogen. Then so at cathode, hydrogen gas is released, at anode, oxygen gas is released. Understood? Now volume of gases, since in water we know water is H2O, that means 2 molecules of hydrogen, 1 molecule of oxygen. So in what ratio we will get hydrogen and oxygen? 2:1. Hydrogen ratio oxygen will be 2:1. And what is the chemical reaction? Again very simple, H2O breaking into 2H2 plus O2. Now H2O is liquid, but H2 and O2 are gases, right? Hydrogen and oxygen are gases, but water is liquid, and that is it. The whole electrolysis of water is completed. Done. And this diagram is also very important, so make sure you are making this. This is my friend, let me write it down. Okay, this is acidified water. Acidified water, why? Because water is a poor conductor of electricity, so we add a little bit of dilute sulfuric acid. These are test tubes. When on anode and cathode we put test tubes. This is just a plastic mug. Okay, plastic mug, and at anode we get O2, at cathode we get H2. Okay, that is it. Done. And this is some source of electricity. Okay, let's move on to the next. We have displacement reaction. What is displacement reaction, my friend? Displacement reaction. Okay, what is displacement? We have studied displacement in 9th class, right? Displacement is speed, velocity upon time, velocity into time, right? Is that what is true in chemistry? No, ma'am, it is chemistry, it is not physics. Okay, now what is displacement? Displacement is displacement of an element. That means that element was there, some other element came, displaced it, displaced it and took its position. That is called displacement reaction. Now understand, a reaction in which a more reactive element, a more reactive atom or element displaces a less reactive element from its compound. Now let's say I am friends with someone, okay? If we are good friends, if we are best friends and very strong and we are very reactive, that means we are not very reactive, we are good friends, our bond is strong. But some third person comes and third person takes my best friend away from me. Now their bond is strong. Why the third person took my best friend away? Because they were more reactive and I was a little less reactive. I was a shant bacha. That person was very, what is that word? Why do I keep forgetting words? What do you say? That person who like talks with everyone. What is that word? Okay, leave it. Whatever. So now that third person come and took my best friend. So now their bond is very strong. Why the third person took? Because he was very reactive, right? So our bond was strong, but the third person came, broke our bond, and now they are a best friends. So when a more reactive atom or person displaces a less reactive element or person is called, from its compound, is called a displacement reaction. Understood? That's a very good example. I think it must have happened with a lot of us. Okay. Now, for instance, when iron is added to a copper sulfate solution. When iron is added to a copper sulfate solution, so iron is Fe, this is CuSO4, right? Solution, it displaces the copper metal and it becomes Fe3SO4 and the copper is now lonely. Okay. So Fe is more reactive, it displaced copper and got with SO4. So Fe plus CuSO4 becomes FeSO4 plus Cu. Understood? So iron displaced copper in copper sulfate compound. Okay, so that means A came, B and C were a strong bond. A came and he kicked B out of the friendship. Now A and C are best friends. B is very, very lonely. Okay, understood? Now the above equation exists when A is more reactive. This is what you need to understand. A should be A should be very, very reactive, my bacha. Okay? Only when A is reactive, then it can kick the C out of the friendship. Okay, now CuSO4 we know have a strong friendship. Zn comes, Zn is also very strong, so it kicks the Cu out, it becomes a bond with SO4, so ZnSO4 becomes, and Cu is again, my bacha, very, very lonely. So because Zn is more reactive than Cu, Zn should be more reactive than this Cu, then only it will be able to break the bond. Understood? Okay. This was displacement reaction. Now double displacement reaction. So in double displacement reaction, what happens is Zn was lonely. That's why it came to break the friendship of CuSO4. But let's say Zn is already with someone else. Okay, ZnCl. So, but now Zn is like, okay, I'm bored. Let me go to CuSO4. So copper is like, okay, you will take CuSO4 from me. I will take the Cl. So they displaces each other's position. The reaction in which two different atoms or group of atoms are displaced displaced by other atoms or group of atoms. These reactions generally occur between two ionic compounds in the solution. Let's read it again, okay? The reaction in which two or more different atoms or group of atoms, let's say two different group of atoms, Na2SO4 and Ba, okay, displaced by other group of atoms. So Ba displaced Na, Na displaced Ba. So they switched their position. These reactions generally occur between two ionic compounds in a solution. That is why both of these are aqueous. Both of these are aqueous. Understood? So we have Na2SO4 and BaCl2. So Na is like, Ba, go away, I want to be with Cl. So Ba is like, okay. So Na takes the position of Cl. It becomes NaCl. So Ba is like, now I am alone. What should I do? Okay, let me go talk to SO4. So Ba is now friends with SO4 and Na is now friend with Cl. So we have BaSO4 and NaCl instead of Na2SO4 plus BaCl2. Understood? Easy. Friendship, triangles, okay, easy. Okay, so displacement reaction is a triangle, but double displacement is not a triangle, it's a square. Okay, let's say whatever you call that. Okay. What's the actual difference? See, displacement reaction, a single displacement reaction, a single displacement reaction is a chemical reaction in which a more reactive element that replaces a less reactive element. General formula is A and B was a compound, C replaced A. So now B and C are a compound and A is lonely. Right? Now in double displacement reaction is a chemical reaction in which two ionic species are exchanged between two molecules. That means A went with C and B went with D. So A and C is a compound now, B and D is a compound now. Earlier A and B was a compound, C and D was a compound. Done? Next, no precipitate formed as a result of color change. Generally, in displacement reaction, color change happens. There is no precipitate. Precipitate is something that settles down. So nothing settles down in the displacement reaction, but in double displacement reaction, precipitate is formed. Hence, one of the examples of double displacement reaction is precipitation reaction, which we will study in a bit. That means, in double displacement reaction, always a precipitate will be formed. Understood? Okay. Next we have precipitation reaction. Now precipitation reaction occur when cations and anions in aqueous solution. Now see very carefully, when we talk about precipitate, we talk about something settling down. That means something settling down in a solution. In an aqueous solution, there is a beaker, you put another substance, that substance reacted with whatever was there in the beaker and it settled down. So it is happening in an aqueous solution. That means there are always cations and anions. You know what cation and anion is, right? So cation is positively charged, anion is negatively charged. So precipitation reaction when occur when cations and anions in an aqueous solution, combine to form an insoluble ionic solid called a precipitate. Whenever a powder is formed, whenever you mix two things together and a powder is formed and it settles down, it's an insoluble solution because it is not soluble and it is called a precipitate. Done? Easy. Now for example, then reaction between silver nitrate AgNO3, reaction between AgNO3 which is a liquid, NaCl which is salt, right? It's our common salt. So when we put common salt in silver nitrate, we get silver chloride AgCl and it settles down. How do we know that? Because of the downward arrow. And NaNO3, that becomes the liquid, the solution. Right? So this whole thing, whenever what is the reaction? AgNO3, when it is reacted with NaCl, it becomes NaNO3 which is a solution, but AgCl settles down. It is a liquid, that AgCl settles down, and you always have to put a downward arrow to depict that someone is settling down, something is settling down, that something is a precipitate. Understood. Next we have reaction between, another example, reaction between barium chloride and sodium sulfate solution. So Na2SO4 BaCl2. Now this was also a double displacement reaction. This is also a double displacement reaction. Ag went with Cl, Na went with NO3. Now here Na2 went with Cl, it became NaCl, and SO4 went with Ba, it became BaSO4, which gives a white kind of powder. This Ba is a white, it's a white powder. And how do I know it settles down? Because of, I have to put a downward arrow sign. Understood? Very easy. Understood? Okay. Let's move on to exothermic reaction. Okay, how many? We have few pages left. Okay, we have few pages left. Now, very quickly, let's study what exothermic reaction is. We know when exothermic reactions in which energy is released, heat is released. So, whenever the heat is released, heat comes out, it is called an exothermic reaction in which energy is released during the reaction, meaning that the surroundings have more energy than they started with. I put a beaker, the temperature around the beaker will get hot, right? The area around the beaker will get hot if it's an exothermic reaction, if heat is released, right? So the temperature of surroundings will increase. The temperature of surroundings will increase. That means heat is getting out, and it is called exothermic reaction. There is an increase in temperature. Generally, combination reactions are exothermic in reaction in nature. When we combine 2 or 3 more substances and a single product is formed, then we generally say, we saw in the examples, right? We generally saw that whenever we combined 2 or more 3 substances, it generally gives us a product. With that, it gives us heat, and that heat is the result of increase in temperature. Very easy. Then moving on, we have few examples like methane, burning of natural gas. So methane plus oxygen, it gives CO2 plus H2O. Right? So it also releases heat. It's an example of burning. So burning means heat is released. Right? Respiration, C6H12O6, it's a bio, okay? Then oxygen is whenever we combine C6H12O6 with oxygen, it gives us carbon dioxide, H2O plus energy. This energy is heat energy, or simply you can say energy is released. Okay. Also, when decomposition of vegetable matter into compost, you have seen a few people doing like biogas and all. So what they do, they take peels of vegetables, put them in the ground, and they bake compost, and then they get biogas from it. So what is that? That also releases, that is also an exothermic reaction. It will get heated, if you must have seen. Okay. Then moving on to endothermic reaction. Endothermic reaction in which heat is absorbed. Endo means, exo means exit, heat exits. Endo means heat comes. Okay. Endothermic reaction. Endothermic reaction are reactions in which energy is absorbed during the reaction, meaning that the surroundings will have less energy. Now surroundings were at 30 degrees Celsius, and in the beaker the elements were getting cold and they want heat. Okay, they want to absorb heat, so they will get it from surrounding, and if the surrounding gives heat, it will get cooler, right? So the temperature will decrease. Temperature will decrease. There is a decrease in temperature. Okay. Generally, decomposition reactions are endothermic in reaction in nature. When one product breaks into 2 or 3, the energy is absorbed and temperature decreases, heat energy decreases. It is endothermic reaction because the energy is absorbed to break those. Right? Whenever we have to break something, we have to give it energy, right? So energy is giving. We are giving the energy to the thing, and it is absorbing the energy, and hence it breaks. It is a decomposition reaction. Some of the examples are thermal decomposition reaction, electrolysis. All of those things we have studied before are examples of endothermic reaction. Now comes a very important thing, and that is oxidation. You know, I gave JAM, IIT JAM, for masters from IIT, okay, and I did it in physics. Done. Now in physics, and I did my graduation in chemistry as well, don't worry. So in that we also had oxidation in physics. And physics also we had. I was very angry, but okay. In that we also have oxidation. So remember how important it is when I say that oxidation and reduction are important, because I was studying when I was preparing for my master's exam as well. Okay. Now, what is oxidation? Simply oxidation, oxygen. Okay, oxidation takes oxygen. It is the addition of oxygen is what is oxidation is. So if we have carbon, we add oxygen in it, it becomes carbon dioxide. So it is oxidation. Okay. Also you can say there are two things: addition of oxygen, removal of hydrogen is also oxidation. Right? Whenever we have something CH4 and we remove hydrogen from that compound, from methane, it is also called oxidation because hydrogen is removed. Okay. Also, we have loss of electrons. Whenever electrons are lost, we have Zn. So Zn lost 2 electrons, it becomes Zn plus 2. So electrons are lost, we have extra electrons, that is also oxidation. So addition of oxygen, removal of hydrogen, removal of electrons or loss of electrons, is all of these are oxidation. That means oxidation state is increasing. Here the oxidation state of Zn is 0, right? But now the oxidation state is 2 plus, from 0 to 2 plus 2, it increases, right? So this is called the oxidation state. So the oxidation state increases while oxidation, right? Understood? Easy. Now there is one more thing that is a little bit confusing. It is oxidizing agent. What is oxidizing agent? Oxidizing agents are those substances which can oxidize other substances, that means they can make other substances lose electrons, gain oxygen or lose hydrogen. This is an oxidizing agent. It made another substance. Here we have Zn. How did Zn lose electrons? Not just by sitting, right? So let's say we put a substance. It's not a correct example, I'm just telling you. We put KMNO4, okay? Or we put any A substance, and that A substance made Zn lose electrons. So Zn, oxidation happened on Zn. But what is this A? This A is an oxidizing agent. That means it did oxidation on Zn, right? So these are the substances that can oxidize other substances. Understood? Easy. Okay. To do so, it will have to gain electron, decrease in oxidation state, and hence it will be reduced. See, Zn, let's say, plus any substance or any heat, and it becomes Zn plus 2 plus 2 electrons. Now where do you think these 2 electrons go? This A will gain these 2 electrons, and its oxidation state is 0 here, and Zn is also 0. So Zn's oxidation state increases, so someone's oxidation state has to decrease as well. So A becomes minus 2. So its oxidation state decreases, and hence it will be reduced. Just give me one more slide to understand reduced. Okay, understood? So Zn lost electrons due to A. So A is what? A is oxidizing agent, is a substance which we can oxidize another substance. Understood? Easy. These are some of the oxidizing agent. KMNO4 in acid solution, KMNO4 in neutral solution, K2Cr2O7 in acid solution, dilute HNO3, concentrated HNO3. You don't have to remember this right now, but it's good if you do, if you want to take on chemistry and science in your +1, +2. You can try to remember those, but remember that KMNO4 in acid solution is an oxidizing agent. That is important. Okay. Now, reduction. What is reduction? Just the opposite of oxidation. In oxidation, we were adding oxygen, removing hydrogen, removing electrons. And in this we will add hydrogen, so addition of hydrogen, loss of oxygen or removal of oxygen, addition of or gain of electrons. Losing electron, gaining electron. Oxidation, reduction. Losing electron, gaining electron. Okay? Adding oxygen, adding hydrogen, and this one is adding losing hydrogen, gaining hydrogen. Okay, I will write it down, don't worry. Okay, So reduction is when electrons are added. So addition of hydrogen, C plus 2H2, CH4, hydrogen is added, that is reduction. Removal of oxygen, whenever H2O, we did electrolysis, H2 and O2 becomes different, then that is a that is redox reaction. But whenever hydrogen is added or oxygen is removed, that is called a reduction reaction. Then gain of electrons, Cu plus 2. Now Cu was plus 2. To make it neutral, we added 2 electrons and that becomes Cu. Done. And here the oxidation state was plus 2. Here it is 0. So oxidation state decreases. So decrease in oxidation state. Understood? Now reducing agent. What are reducing agent? The substances which can reduce another substance. Reduce another substances means gain of hydrogen, gain of electrons, loss of oxygen. So in this again this example, Cu plus 2 plus 2 electrons, right? It gives Cu. What made this Cu lose electrons? Let's say we added another substance plus B, right? So this B gave 2 electrons to Cu to make it zero oxidation state. So this B reduced copper. This B made reduction happen with copper. That is why B is a reducing agent. Any substance that reduces the another substance is called reducing agent, or which will give electrons. So this 2 electron B gave, right, and will be the B itself oxidized. Why? Because for B is losing electrons, right? B is losing electrons and giving it to copper. So B is losing electrons. If B is losing electrons, then losing electrons means oxidation, then B is oxidized. Okay, but it reduces copper. So B is a reducing agent that itself oxidizes, itself lose electrons. Then as the substances undergo oxidation are reducing agent. Let's I know it's a little bit of confusing. I also used to get confused. Oxidation and reduction, right? Now oxidation is addition of, we say addition of oxygen, and reduction is addition of hydrogen, right? Hydrogen. Now oxidation is removal of this is what? Removal of hydrogen, and reduction is removal of oxygen. Reduction is removal of oxygen. Understood? Then electrons. For oxidation, it loses electrons. And for reduction, it gains electrons. Understand? This will be a little bit more clear. This will be a little bit of more clearer, right? Then oxidizing agent. We have oxidizing agent, and we have reducing agents, right? Now oxidizing agent is something that oxidizes. Okay, there is a substance A. Now A will, and there is another substance B that wants to oxidize and then wants to reduce. So A, and we have, okay, let me do one thing. We write a sentence. Okay, we write a sentence here. Okay, here we write that A oxidizes B. Okay, A oxidizes B. So what will be A? The oxidizing agent will be A, right? A will be oxidizing agent, and B will get reduced. The reduced B. Done? Oh no, sorry. Oxidizes. B get oxidized. Understood? B is losing electrons, A is making it lose electrons. So A is an oxidizing agent. But if this is losing electrons, this is losing electrons, then A is making B lose electrons. So that means A is gaining electrons. So B oxidizes, but A is reduced. Do you understand? A oxidizes B. That means B is getting oxidized. Oxidized means it is losing electrons. A is making B lose electrons. That means A is an oxidizing agent. So A is making B lose electrons. But if B is losing electrons, where are those electrons going? A is gaining electrons. So A itself is getting reduced by oxidizing B. So A is like compromising, A is sacrificing for B to get reduced, B to get oxidized. Done? Let's understand again. Don't worry. Okay. So now let's see reducing agent. Done. Let's again write that A now. Okay, let's do with another. Okay. C reduces D. So what is reduced? D is reduced. This is clear. What is reduced? Reduced is D. Done. D is reduced. But how D is reduced? If D is reduced, that means D is gaining electrons. D is gaining electrons. Right. Now if D is gaining electrons because of C, so C will be a reducing agent. This is clear because C is making D gain electrons, making D reduced, so C is reducing agent. Now C is making D gain electrons. Done. Now if D is gaining electron, that means where are those electrons coming from that D is gaining? C is giving it. So C is losing electrons. That means C itself, that C oxidizes, because oxidation means losing electrons. C is losing electrons, so it oxidizes. It is losing those electrons and giving it to D. D is gaining electrons. Gaining electron is reduction, so D is reduced, C oxidizes. And similarly here, let me change the color, okay? Similarly, A is making B lose electrons. So B is losing electrons, B oxidizes. A is gaining those electrons, so A is getting reduced. But A is making B lose electrons, so then A is oxidizing agent. Understood? It's pretty clear now. Okay? Okay, let's move on to the next thing called redox reaction. Now we talked about water, right? Now water is splitting into hydrogen and oxygen. So hydrogen is different, oxygen is different. Or let's say there is a reaction in which hydrogen is gained, oxygen is released. Oxygen is gained, hydrogen is released. So in which oxidation, that is losing of electrons, and gaining of electrons, both of these are happening. That is called redox, reducing plus oxidation, redox reaction. The reaction in which both oxidation and reduction are happening simultaneously is called redox reaction. Redox reaction can be split into two halves, namely oxidation half where oxidation takes place, reduction half where reduction takes place. Let's understand. Now this is iron. Okay, let me make this again because I don't know if you are able to see this. Iron plus O2 gives Fe2O3 plus O2 gives Fe2O3. Okay, now understand that for iron is gaining oxygen. Okay, iron is gaining oxygen. Understood? That means it's oxidation. Understood? And plus water also comes out, H2O. Now oxygen is gaining hydrogen, right? So this is reduction. This is reduction. Understood? So we are gaining oxidation, we are gaining hydrogen, that means reduction, and that is what is a redox reaction is. Oxidation and reduction combinedly happening in one single reaction is called redox reaction. Okay everyone, done beta? Okay. Next we have effect of redox reaction in everyday life. Reduction, oxidation. Why are we studying this? Because see beta, there in this environment we have hydrogen, we have oxidation, oxygen all around us. So on my body there are million molecules of oxygen right now, and if something that reacts with oxygen, I don't react with oxygen, I breathe it in, right? But inside oxygen reacts with blood, makes hemoglobin. So what do you say? Oxygen is reacting, oxidation. Hydrogen is also there, hydrogen is reacting, reduction. So there are lots of effects these hydrogen, oxidation, these redox reaction makes in our daily life. Okay, so the first is corrosion. What is corrosion? Do you have like iron gates, right? Iron gates in your home, metal gates in your home, and you see after some time a brownish substance is like it's getting out of that gate, or a brownish substance is like there on the gate and looks really bad. That is corrosion. What is happening? The process of slow degradation of that metal. That metal is getting degraded, right? That metal is getting degraded due to the attack of oxygen, atmospheric gases like oxygen, moisture, acids on that surface. Due to moisture has oxygen in it. Due to acids also have lots of oxygen, hydrogen in it, right? So due to that the metal is gaining or reducing, losing electrons. That means that metal is getting degraded due to the effect of atmospheric gases, moisture on it, and the surface of metal gets very degraded. It's called corrosion. So the process of slow degradation of the metals due to the attack of atmospheric gases like moisture, like acid on the surface of the metal is called corrosion. Corrosion is a natural process. Of course, there are lots of gases in our atmosphere. That is natural. So it's a natural process which converts a refined metal, a good metal, to its oxide. See, it is reacting with oxygen, right? I told you. So the metal, when reacts with oxygen, it creates its oxide. That means oxidation happens, right? Hydroxide, when hydrogen and oxygen both reacts with it, or sulfides. Sulfur also is a makes the metal degrade, right? So if the metal is converted into its oxide, hydroxide or sulfide, we say the metal is getting degraded and it is getting corroded. Example, iron forms that reddish brown colored coating on its outer surface due to corrosion. Understood? Understood? Iron forms a reddish brown coating on its outer surface called corrosion. So how will you write? The process of slow degradation of metal due to the attack of atmospheric gases or atmospheric moisture and acids, it's called corrosion. Example, reddish brown coloring on the outer surface of iron is called corrosion, right? Now, of course, we have to protect our metals. We can't change our gates every year or every month, right? Let alone every day. So we have to protect. So how do we protect it? We use some layers. We put some layers on the metals so that it, just like we put layers of clothes on our body to protect us from heat, to protect us from extreme weather, and we put jackets to protect us from winter, right? Similarly, we put coating on the metal surface to protect it from atmospheric gases, acids or moisture, right? So corrosion of iron is called rusting. First of all, that iron has, it is so common, we have given it a name. So the reddish brown coating on iron surface, it's called rusting of iron, okay? And it's a serious problem. It's very serious problem. Every year so much amount of money goes into changing those corroded metals, replacing those corroded metals. You know, Statue of Liberty originally was not of this greenish color. It was not a greenish color. It actually was a metal. It got corroded and now it looks like this. Okay, it's iron, I guess, and now it's look like this. It's rust. It's not the original color. Okay, so every year lots of money is spent on these damaged iron. So what we did, let's not spend the money to correct this, let's spend the money to protect this. Okay, prevention is better than cure. So coating, first the process of corrosion and can be prevented by applying a layer or a coat of non-corrosive metal. There are metals which are not affected by these atmospheric gases, moisture, acids. So what we do, we take those metals, we put them into a small layer, and on our metal we coat that layer. Now this is not corrosive, right? This can't be corroded. Now put it on an element which can be corroded, so this is protected now. Okay, oof, it's been let me have some water. It's been a long time since I'm teaching you, right? Okay, so the process of corrosion can be prevented by applying a layer or a coat of non-corrosive metals, the metals which are no effect of gases and oxygen on the surface of metals which must be protected. Then the metals can be coated with epoxy. Have you seen epoxy? There is a lot of new trend around epoxy that you protect your wedding bangles or some stuff. You make earrings of epoxy, and you see if you have roses or flowers and you put that in a container, put epoxy, it won't get bad for years to come, right? That is what epoxy is. Epoxy actually protects our metals. So we put a coating of epoxy on metals as well, and acrylic to reduce their corrosion. Done? Okay, very good. Now, what are other methods? Oiling the surface. The oiling of the surface is also a very, very important method. The corrosion of metal can be prevented when the surface are oiled or greased. We know oil does not react with water, so it won't react with moisture. Oil and water are like enemies, right? You have seen when you put oil in water, the drops are floating otherwise and the water is somewhere else. It's called hydrophilic, hydrophobic. You might have not studied that by now, but it's a very, very interesting concept. So oil and grease are hydrophobic, that they don't like water, so they stay away from water, and hence they end up protecting our metal surfaces. And paint also, there are oil based paints as well. Okay, so paint provides a protective layer on that metal. Paint can help in the prevention of corrosion. Paint must be applied regularly to do this, because we know paint also gets bad after some time. So you have to apply paint regularly to protect our metal, right? Next we have galvanization. Now this is very important and very different as well. Galvanization is again a method of preventing our iron, the steel, the metals by coating from rusting, by coating them with a thin layer of zinc. Galvanization, you have the sound, that means it is a zinc layer. Galvanization, zinc, thin layer. So we coat a thin layer of zinc on our metal, that is our steel, that is our iron, and hence it prevents from corrosion or rusting. Understood? Okay. Moving on, there is one more thing, that is effect of redox reaction. The other thing is rancidity, whatever you want to call it. Now, rancidity is something that happens to food. Metals in air, they get bad, corrosion. Food in air also gets bad, that is rancidity. So spoilage of food in such a way that it becomes undesirable and unsafe for consumption. We get a bad odor from food. Sometimes the yeast forms upon the food, right? Too much yeast that we can't eat it. So those are the things also happening due to this effect of atmospheric gases on the food, and that is what is a rancidity. Okay, it is characterized by an unpleasant smell and taste as well. The term rancid applies to oils and fats. So what happens? Our food has oils, our food has fats in it, right? So those oils and fats, they interact with oxygen, interact with atmospheric gases, and they get oxidized. right? When food scientists talk about rancidity, what have I written? Okay. So, food scientists talk about rancidity. They are often talking about the type of rancidity in which food is damaged due to oxidation. Told ya, food is damaged due to oxidation. It is termed as oxidative rancidity, because the foods, the oils and the fats, they get oxidized, and that is what we call oxidative rancidity. That means the spoilage of food due to the oxidation of fats and oils in it. Done? Okay. Next, we have how to protect rancidity. Again, we need a solution, right? We are not just studying science for just knowing those facts. We need the solution as well. Use of antioxidants. Antioxidants are those substances that prevent oxidation. Very easy. Sodium bicarbonate is one of a great antioxidant. If you put that in your food, of course too much of that it's harmful, but in a limited limit, if you put it, then it will keep your food last a little bit longer. Okay, then we have use of nitrogen gas. We know when we open the packet of Lay's, air comes out of it, right? So that air is nitrogen gas. Why? Because nitrogen gas is added during the packaging of the potato chips to prevent oxidation of fat and oil. Nitrogen gas is an inert gas. Inert gas means it does not interact with other elements in the air and stuff. So when you put it in the packet, it does not react with oils and fats and keep it safe for consumption for a longer period of time. See, Lays are being made in somewhere in USA or UK, their factories are, right? Or somewhere in India as well, they have factories, but it's not right next to our house, right? After from coming out of oil, it directly goes into our plates. No, they are packed. When they pack, the oils and fats can get bad, they can get oxidation. To prevent the oxidation, we put nitrogen, because nitrogen does not react with oils and fats, and hence the oxidation is prevented, and hence the chips doesn't go bad. Right? Now, use of airtight containers. Airtight containers, that means air is not going inside them. If air is not going inside them, it won't react with oils and fats, won't react with air, and hence the food is prevented. Right? Preserving food in airtight container reduces its exposure to oxygen, and this slows down the oxidation process. Use of refrigerator. When you keep the things cool, the oils and fats are prevented, and hence it slows down the oxidation or rancidity as well. Done? Okay. Oh, thank you so much. That was it for this video. We have finally completed a very, very, very important chapter of our class 10th, the OG series, and all 2 other chapters are already there on the channel beta, chapter Light and Human Eye. Make sure you are revising all of these, all the one shots I'm putting out. You have to complete them in the summer vacations beta, please, because that will put you ahead of your peers, 95% of your peers, and that is what we want, right? We want to complete our class 10th and become the OG of class 10th. That's why this series is called OG series. That is it for this video. I'll meet you in the next one. Make sure you practice some questions, and I will come live to do these questions as well. Okay, so I will meet you in that session. Tada, bye bye, love you all.